Okay, so erythrocytes, which are the most plentiful of the formed elements, and I just give you a little bit of a ratio here. You don't have to remember that, okay? And they represent a lot of the cells in the body, are extremely short-lived as far as cells go. They maybe live 90 days. They look like these little discs. You know, if you look, this is a scanning electron micrograph, I believe, of them. And they are biconcave discs, perfectly round for the most part. So no matter how you look at them, right, diameter is the same. Right? No organelles. They've lost everything in the process of their being formed in the red bone marrow. So prior to losing everything, of course, what they did is made a lot of hemoglobin. And so I say these are basically bags of hemoglobin. Reticulocytes is the stage just before they become a mature erythrocyte. And so reticulocytes are cells that actually are released into circulation. And this is about 1 in every 100 red blood cells is really considered a reticulocyte. It still has remnants of the endoplasmic reticulum, but those remnants will be ejected from the cell, exocytosed in a matter of a couple of days, and they will solely be these, homogeneous looking little membranes of hemoglobin, right? So this is a cartoon of the hemoglobin as it would look with the protein folding. This is just the chemical or structural formula for the heme part of this, right? And so, and this is the important part because it's the iron that binds the oxygen. So I say here again, you don't have to know the amount of hemoglobin you should have, this male and female, but note that it is going to transport almost all of the oxygen in the blood and about a quarter of the carbon dioxide. So in the lungs, it picks up oxygen, and so it's called oxyhemoglobin, and it changes its shape, and thus it appears a very bright red. As it moves away from the lungs, it'll start delivering. So away from the lungs, comes back to the heart, right? And the heart then pushes it out to the body. And in the body tissues, depending on how much oxygen they need, the cells will gradually take up this oxygen. In other words, it'll be unloaded from these heme, all right? And so it becomes deoxyhemoglobin, which means it turns into kind of a dark red color. This makes total sense. Again, I said everything is about meeting your body's needs. So the needs of the body determine how much oxygen is released. So the more oxygen you're using, think like skeletal muscle, the more oxygen that will be delivered from this molecule. All right. I also mentioned that as those cells in your body are using oxygen, of course, in cell respiration, they start producing carbon dioxide. So carbon dioxide is actually bound to hemoglobin as well. And so we talk about a carbaminohemoglobin, right? And the majority of the molecule is protein. So, and I said here that, per red cell, you can move about 1 billion oxygen molecules, right? So that's its job. How do we keep it constant? And how then do we change it when our needs change? So again, I say production has to keep pace with destruction. So if I'm, killing 1,000 a second, I need to have 1,000 a second made, right? Again, you don't have to know numbers because that's not the point of this. You can always look those up. This just gives you an idea about there's a lot of red blood cells in there. All right. If you have too many of these, we call it polycythemia, and that means you're too viscous. If there's too few, you have anemia, but more importantly, you suffer from hypoxia, right? Low oxygen levels. All right. So we maintain this homeostasis, of course, by the use of erythropoietin. All right. And then the nutrients that we take in, right? So iron, copper, zinc, amino acids, and folic acid, B12 are the important nutrients that are going to help us build that hemoglobin molecule. All right. So this cartoon shows this kind of life of the red blood cell. And I say, you begin with the cooperation of the kidneys, which are monitoring oxygen levels, the GI tract, which is allowing the absorption of nutrients, and of course the red bone marrow, which is actually producing the cells. All right. So here they remark that here's your number one. We've got hemopoiesis and red bone marrow. All right. So you go through the cycle, you release reticulocytes, they become red blood cells, and you just move. All right, you circulate for about 120 days, passing through these very narrow capillaries, which is one of the reasons why you're so small, of course, loading and unloading oxygen and some carbon dioxide. All right, so after this time period, you become you've worn your proteins wear out. You have no way to repair yourself, so you're going to be removed from circulation by the liver and the spleen. Okay, in the liver and the spleen, there would be macrophages that are going to be able to consume that worn out red blood cell, because the macrophage is much larger, and the lysosomes merge with the lysosome and break it down. So you're going to recycle the globin part and break it down into its individual amino acids, and I can reuse those for anything. And then the heme part, right, the non-protein part, will take a different route. Okay, so it shows you here that the amino acids and cell components can be back, they can be recycled here, they can be used anywhere. The heme part will be broken, the iron will be removed, and the iron is bound and then can be stored in the liver or sent back to the bone marrow. The heme part is broken down, especially in the liver, okay? And it is, because if it was broken down in the spleen or bone marrow, we just move it to the liver. And in the liver, it will be converted chemically to biliverdin and then to bilirubin. And at that point, it can be released in the bile, and the bile can then be used in the digestive process, as we'll talk about this. You certainly do not want your red blood cells rupturing while they're in circulation, because if they do, they will release this huge intact protein, hemoglobin, which could damage the kidneys. All right? So problems with production, we look at size. Are they the right size to make it through the capillaries, or shape? Again, think about the pathologies like sickle cell anemia, why that's a problem. The absolute number of them and the amount of hemoglobin they have. So all of these could factor in a problem with production and circulation. So when the number of red blood cells or hemoglobin is sufficient, we use the term anemia. All right, and there's a lot of different really ways, causes and types of anemia, but we just want you to understand that's what anemia is. All right, so 3 major reasons we would get to this point, anemia, would be we lost blood, we have a problem in producing our red blood cells, so bone marrow problems or nutrient problems, or we have an excess destruction of them. And this, of course, results in low oxygen. All right, so this leads to low oxygen, and this means that eventually the rest of the body has to work harder to try to maintain homeostasis. All right, so here, looking at the causes that we mentioned in the last one, here's a photo of sickle cell anemia, and so this would be a faulty or decreased red blood cell production. Okay, blood loss. Clearly, there's a lot of reasons you can have blood loss, and I'm not going to ask you the reasons for blood loss, but this is just like I said. You should know that blood loss would be a cause of anemia that would lead to hypoxia. Faulty or decreased red blood cells. Again, here's reasons. Nutrients and genetics are really the top reasons here. And diseases of the bone marrow or stem cells abnormal, those could all be reasons. Excessive destruction, hemolysis is a term we use here. And here's some, again, basic reasons you might get hemolysis. And they all have in common, again, that they will lead to this situation of anemia and hypoxia. All right, too many of these would be polycythemia, and it's not better to have more, because this will make the blood flow slower, and this will increase your risk for clotting, as well as put a higher workload on the heart. And we just qualify 2 types of polycythemia, but again, here you should just know that polycythemia means we have too many red blood cells. All right, in the next video, we'll look at the white blood cells.